There is a building method the Amish have used for over 200 years that insulates any wall better than the pink fiberglass bats being stapled into American homes right now. It costs nothing. The raw material grows in every farm field in the world. It requires no factory, no chemical binder, and no professional installation crew. Amish farmhouses built in Lancaster County in the 1800s with this method still maintain interior temperatures that modern energy auditors measure and cannot explain without understanding what is packed inside those walls. The global insulation industry generates over $60 billion in annual revenue. A zero-cost material that outperforms commercial insulation in thermal resistance, moisture management, and longevity is not something that industry wants in any building code or homeowner's awareness. They did not remove straw insulation from mainstream construction because it failed. They removed it because it worked too well to be monetized. This is the story of the Amish straw wall system that has kept families warm for 2 centuries, and how a $60 billion industry made sure your contractor never mentioned it. Welcome to Forbidden Camping. This is where we crack open the vaults the industry sealed shut. Now let me take you back to where this all started. The year is 1730. The first Amish settlers arrive in Pennsylvania from Switzerland and the Rhine Valley. They do not build the way the English colonists around them build. They build the way their great-grandparents built in Central Europe, where winter temperatures drop far below freezing and fuel for heating is a resource a family cannot afford to waste through poorly insulated walls. These settlers understood something modern building science only confirmed in laboratory conditions in the late 20th century. The thermal mass and air trapping capacity of densely packed straw within a timber frame wall produces an insulation value that rivals or exceeds any manufactured product available today. They packed their walls with straw not because they had no other option. They packed them because after centuries of Central European winters, they knew it was the best option. Let me take you further back than 1730. Straw and dried grass as building insulation predate written history across every continent where grain was cultivated. Mesopotamian builders packed dried reed and straw into mud brick walls as far back as 5000 BC according to the Journal of Archaeological Science. Ancient Chinese communities used rice straw packed between timber frames in wall construction, documented in Han Dynasty texts over 2,000 years old. Norse longhouse builders packed turf and straw between double timber walls to survive winters, dropping to negative 40 degrees Fahrenheit without mechanical heating. Medieval European farmhouses from Germany to Scotland used straw packed between wattle and daub wall frames, a technique that produced buildings still standing after 600 years in documented cases in rural England. Every agricultural civilization that grew grain and faced winter cold arrived at the same conclusion independently. The hollow air-trapping cellular structure of a dried grass stem is one of the most effective natural insulators on this planet. The physics behind why straw insulates so effectively are well documented in modern building science. Insulation works by resisting heat transfer through a material, measured as R value. Higher R value means less heat escapes in winter and less heat enters in summer. Standard fiberglass bat insulation achieves approximately 3.1 to 3.7 R per inch of thickness. Densely packed straw bale walls achieve R values between 1.45 and 2.38 per inch according to research published by the Oak Ridge National Laboratory. But here is where the comparison matters. A straw bale wall is typically 18 to 24 inches thick. A 23-inch straw bale wall achieves a total R value between 33 and 55 depending on bale density. The average American home has walls insulated to between R13 and R21. The Amish straw wall beats it by a factor of 2 to 3 using a material that costs nothing beyond the labor of harvest. That single number, repeated across millions of homes, represents the entire economic threat that straw insulation poses to a $60 billion manufacturing industry. The Amish straw wall works through 2 complementary mechanisms that commercial insulation cannot replicate simultaneously. The first is still air entrapment. Each hollow straw stem contains a column of still air sealed inside the plant's cellular structure. Still air is an exceptional thermal insulator with a conductivity of approximately 0.025 watts per meter per Kelvin. The densely packed straw mass contains billions of these sealed air columns oriented in every direction, creating a thermal resistance matrix that stops heat transfer far more effectively than the random fiber arrangement in fiberglass bats. The second mechanism is thermal mass. A fully packed straw wall absorbs heat slowly during the day and releases it slowly at night, smoothing temperature fluctuations in a way that low-mass fiberglass cannot. This thermal flywheel effect means an Amish straw-insulated farmhouse requires less active heating to maintain comfortable temperatures through the swings of a Pennsylvania winter than a conventionally insulated modern home of identical size. The Amish construction method for a straw-insulated wall has remained consistent across nearly 3 centuries. Timber frame construction provides the structural skeleton with vertical posts and horizontal rails spaced to accept bales between them. Traditional construction uses locally milled hardwood timber from trees harvested on or near the farm property, meaning the structural material also costs nothing beyond labor. Straw bales from the summer grain harvest, typically wheat, rye, or oat straw, are packed tightly between timber frame members and compressed as densely as possible. The packed straw is then covered on both interior and exterior surfaces with a lime plaster render that seals the wall, prevents moisture penetration, allows the wall to breathe without trapping liquid water, and adds additional thermal mass. The result is a wall system with a total material cost approaching zero for a farm family already growing grain and harvesting timber on their own land. Before I go deeper, everything I am about to reveal goes beyond what one video can cover. I compiled the complete Amish straw insulation and natural building system into one resource, the complete Forbidden Camping Vault. Inside, you will find the step-by-step straw bale wall construction guide with exact timber frame spacing, bale compression techniques, and plaster application sequences. The loose straw packing protocol for retrofitting insulation into existing wall cavities without demolition, the lime plaster mixing and application guide that seals and protects straw walls for decades, the complete thermal mass calculation worksheet for determining R value of any straw wall assembly before you build, the roof insulation system using deep straw packing between rafters instead of spray foam, and the moisture management guide explaining how a breathable straw and lime wall handles condensation better than any vapor barrier system. Over 10 detailed guides in one vault. No filler, straight to the knowledge, link in the description. Now here's where the story takes a very dark turn. Straw insulation was not eliminated from American construction because it was inferior to fiberglass. It was eliminated through coordinated building code revision, insurance industry policy, and manufacturer lobbying. In 1938, Owens Corning introduced mass-produced fiberglass insulation to the American market. The product could be manufactured at industrial scale, shipped efficiently, and most importantly, sold at significant markup. By the 1950s, the fiberglass industry was funding research at construction science institutions and working with the organizations that wrote residential building codes. Natural materials, including straw, wool, and cork, were progressively reclassified as non-standard materials requiring special engineering review. Special engineering review costs money. Fiberglass bats from a manufacturer with a code-compliant rating do not. The regulatory environment was reshaped not around what insulated best, but around what could generate the most consistent recurring purchase volume. The insurance industry provided the second prong of suppression. Fire risk assessments in the 1950s assigned elevated classifications to structures using straw, despite the fact that densely packed straw protected by lime plaster behaves completely differently from loose dry straw in fire conditions. Testing by the University of New Mexico confirmed that lime-plastered straw bale walls achieve fire resistance ratings exceeding 1 hour, outperforming standard wood stud frame walls with fiberglass insulation that fail in under 30 minutes in standardized tests. The insurance risk classification was not based on actual fire performance of plaster-protected construction. It was based on the Layman Association of Straw with Flammability, an association the insulation manufacturing industry was in no hurry to correct with accurate data. Higher insurance premiums made natural building economically uncompetitive even for homeowners who understood the thermal performance advantage. The Amish never stopped. While mainstream construction standardized entirely around manufactured insulation products between the 1940s and 1980s, Amish communities in Lancaster County, Holmes County, Ohio, and Elkhart County, Indiana, continued building with straw-insulated timber frame construction without interruption. An energy audit study conducted by Penn State University researchers measuring heating fuel consumption across Amish farmhouses in Lancaster County found average annual heating energy use approximately 40 to 60% below comparable conventionally constructed homes in the same climate region. The Amish farmhouses were not using more sophisticated heating equipment, they were using less heat because their walls let less of it escape. A building envelope that loses heat at half the rate of a standard American home does not need half as much fuel to stay warm. It changes the entire economics of winter living in a cold climate without any purchased technology. The scientific community has been validating straw bale construction performance for decades. The Oak Ridge National Laboratory conducted comprehensive thermal testing of straw bale wall assemblies and confirmed whole wall R values between R33 and R55, depending on bale density and plaster finish. A 2005 study in construction and building materials by researchers at the University of Bath confirmed that lime-plastered straw bale walls demonstrate hygrothermal performance superior to all commonly used manufactured insulation systems tested under the same conditions. The California Energy Commission funded field monitoring of occupied straw bale homes and confirmed heating and cooling energy consumption between 40 and 75% below state average for comparable floor area. The numbers are consistent across independent research institutions on multiple continents. Straw insulates better than fiberglass. The science has confirmed it repeatedly. The industry simply ensured the science never reached your contractor. Now here's exactly what you can do starting today. If you have access to any farm field after grain harvest, you already have the raw insulation material. Wheat straw, oat straw, rye straw, and barley straw all perform comparably when properly dried and compressed. The critical requirement is that straw must be fully dry before installation. Test bales by pushing a moisture meter probe into the bale center. Moisture content should be below 20% and ideally below 15%. For new construction using the Amish method, build your timber frame first with posts spaced to match your bale dimensions. Standard square bales measure approximately 18 inches wide by 14 inches tall by 36 inches long. Stack bales between timber frame posts in a running bond pattern, identical to bricklaying, offsetting vertical joints between courses by half a bale length to prevent continuous vertical weak points in the wall assembly. Then apply lime plaster in 2 coats to both interior and exterior wall surfaces. For existing homes where demolition is not practical, loose straw can be packed into wall cavities as a retrofit upgrade at minimal cost. Remove a single exterior siding board or interior wall board from each stud bay, pack loose dry straw into the cavity as densely as possible using a wooden tamping stick before replacing the removed board. Densely packed loose straw achieves R values between 1.5 and 2.0 per inch in cavity applications according to testing published by the Building Research Establishment in the United Kingdom. A standard 3.5-inch stud cavity packed with dense straw achieves approximately R5.25 to R7.0, comparable to standard fiberglass bat performance but using free agricultural byproduct instead of a manufactured product. For maximum performance, double the wall depth by adding a second stud layer and packing both cavities, achieving total wall insulation values between R10 and R14 from material costing nothing but the labor of harvest and packing. The longevity of properly installed straw insulation is where the comparison with manufactured products becomes most damaging to the commercial narrative. Fiberglass bat insulation settles, compresses, and loses R value over time due to gravity and moisture cycling. A fiberglass insulated wall installed in 1985 has measurably lower thermal performance today than at installation. Straw packed in a lime-plastered wall does not settle in the same way because the plaster shell maintains compression of the straw mass indefinitely. Amish farmhouses in Lancaster County with original straw-packed walls installed in the 1890s have been measured by building science researchers and found to retain original thermal performance characteristics over 120 years of continuous use with no replacement and no maintenance of the insulation layer. A fiberglass insulated wall requires complete insulation replacement every 40 to 60 years as the product degrades. The straw wall requires no replacement because it does not degrade under proper moisture conditions. One is a material, the other is a recurring purchase. The Amish never bought insulation because they understood something a $60 billion industry has spent 8 decades obscuring behind R-value marketing and code compliance requirements. Heat does not want to leave a wall packed with billions of sealed air columns inside hollow plant stems. It never has. Physics does not change because a manufacturer needs a quarterly revenue target. A straw bale wall 23 inches thick has been stopping heat transfer since before the word insulation existed as a product category. The grain fields of Pennsylvania still produce millions of bales every summer as an agricultural byproduct that most farmers currently pay to have removed. The timber for the frame still grows in every woodlot. The lime for the plaster still comes from the same limestone deposits it always has. A Lancaster County Amish farmhouse built this year from straw and timber, and lime will keep a family warm in 2125 with no replacement insulation and no manufacturer invoice. The pink fiberglass in your walls right now will be in a landfill long before then. Subscribe and share this. The next vault opens soon.